topic is the effects of electric current. So to truly understand or to visualize or conceptualize, to truly understand the effects of electric current, let me show you a video.
Consider a glowing bulb. What happens when we place our hands near a glowing bulb?
Our hands get warm.
But do you know why? We can understand this by studying the different effects that the electric current produces. The three common effects of electric currents are production of heating, magnetic, and chemical effect. Let's study each effect one by one. First, let's study the heating effect. Going back to the example, when the current passes through a light bulb, some of the energy is used to produce the light in the bulb, and the remaining energy dissipates in the form of heat. When the current passes through a filament of tungsten, a rare element used to make the wire in bulbs, some of the electrical energy produces heat around the bulb. This is called the heating effect of electric current. Let's take a closer look to understand how this happens. When electrons pass through tungsten wire, they give some of their energy to the atoms in the wire. When receiving this energy, the atoms vibrate. It is these vibrations that heat up the wire. This effect heats up many things, including electric irons, heaters, toasters, and kettles.
Then why don't the wires in our homes heat up?
The wires used in our homes do not produce any heating effects. They are made of materials that have low resistance that allow the current to flow through smoothly. Secondly, an electric current produces magnetic effect. Do you recognize this object?
This is a magnet. It attracts objects made of iron.
Yes, and this is a magnetic compass. There is a pointer inside of its glass chamber that points us in the right direction. Now, observe what happens when we bring a magnet near the compass.
Its needle deflected.
Now, let's test an idea. If we bring a compass near a wire conducting electricity, the needle will deflect the same way it does with a magnet. Time to perform a simple experiment to test this hypothesis. Create a circuit with a battery and switch. Now pass the current through the wire, holding the wire on top of the compass. Did you notice what happened to the compass needle?
Wow! The needle deflected.
This shows that an electric current can also produce a magnetic effect. A magnetic effect can be produced in a metal, like iron, by coiling a wire around it. The iron nail behaves like a magnet when an electric current passes through it. Magnets like these are called electromagnets. When the current stops flowing, the electromagnet loses its magnetism. The application of this effect is used in telephones, electric bells, and loudspeakers. Lastly, let's have a look at the chemical effect of electric currents. Let's illustrate this process with an example. Fill a beaker with sodium chloride and set up the circuit like this. This is a negative electrode as it is connected to the negative terminal of the battery, and this is the positive electrode as it is connected to the positive terminal of the battery. When using an electrolyte, a solution that conducts electricity, Like sodium chloride, an electrode is the conductor through which an electric current will either enter or exit. Now, observe what happens when current passes through the solution.
Chlorine gas is collected through the positive electrode and sodium through the negative electrode.
This is an example of the chemical effect that results from the flow of current. Currents break down the compound into its components. This is called electrolysis. This chemical effect is used for electroplating, a process in which one metal coats the other. For example, the rims of a bicycle are coated with nickel. Sometimes even jewelry is coated with gold to enhance its beauty. Time for an exercise. Pause this video to discuss this question. Closely observe the process in the diagram. What is the effect taking place? Notice that the battery is connected to positive and negative electrodes that are dipped in a solution of copper sulfate. When the current passes through the solution, copper sulfate breaks down into copper and sulfate through electrolysis. Copper is collected through the negative electrode and sulfate through the positive electrode. This is an example of the chemical effect caused by the flow of a current. To summarize, electric currents produce three major effects. They produce heating, magnetic, and chemical effects.
So from what we've seen in the video, ato siyang i-summarize. So in simple summary, we have three main effects of electricity. We have number 1, heating effect. Number 2, magnetic effect. And number 3 is the chemical effect. So in heating effect, current passing through a conductor produces heat due to resistance. So from what I've discussed earlier, and when there is a collision between electrons, mag-create na siya og heat. Right. Number 2, we have magnetic effect. A current carrying wires create magnetic field around it. So ma-use ni siya sa mga motors, kanang motors nga kanang sa mga duaan or sa mga motors good sa like sa mga electric fan or electromagnets. Number 3, we have chemical effect. Electricity can cause chemical reactions in a solution called electrolysis. So from what the video nga atong nakita ganina nga katong compound kay iya siyang katong banded nga compounds ba iya tong gi-unband using electricity. So in simple summary, electricity can be converted into heat, magnetism, and chemical reaction or chemical changes, which is why it is widely used in our everyday devices. So there are many application of electricity, no? That's why we are so reliant on electricity because of its help nga mapapaspas atong mga buluhaton sa taga-adlaw-adlaw. Right.